The universe is everything that exists. It is all matter, energy, space, and time combined into one system. It is not a place things sit inside. It is the total sum of what there is. People started studying the universe because looking at the night sky raises real questions. How big is it? How did it start? Will it end? Where do you fit inside it? For most of history, these questions had no answers. There were only guesses passed down as stories. Modern tools changed that completely. Telescopes, spacecraft, and particle detectors turned guesswork into a working model. That model can be tested and checked against real data. The universe was never mysterious by nature. It was simply too big and too old to measure until recently. The ideas involved are not complicated once someone lays them out in order. You do not need a background in physics to follow them. You just need each piece explained clearly, one at a time. Now you can understand it in plain terms, without guesswork. You can use the same basic ideas scientists use every day. Space is the first idea to understand. Space is the three-dimensional area everything exists in. It is not empty in the sense of being nothing. It is a real, measurable dimension, the same way length and width are real. This matters because distances between objects define how the universe gets measured and mapped. Every measurement in astronomy starts with a distance through space. Consider GPS satellites orbiting above you right now. They rely on precise timing signals sent through space to calculate your location. Those signals travel at a fixed speed and cover a fixed distance. If the distance calculation is off by even a fraction, your position shifts. That shift happens on the ground, right where the work gets done. A construction crew laying a foundation using GPS could end up off by feet. That kind of error is expensive to fix once concrete is poured. That error comes directly from miscalculating distance through space. Space is the measurable distance between everything that exists. Time is the next idea, and it connects directly to space. Time is the fourth dimension, and it cannot be separated from space. Physicists treat space and time as one combined system. This matters because looking far away always means looking into the past. The farther away something is, the older the image you are seeing. Sunlight takes about 8 minutes to reach Earth. The sun you see right now is actually 8 minutes old. If the sun stopped producing light this second, you would not know for 8 minutes. Everything would look completely normal until that light ran out. That gap between an event and when you observe it applies to everything in space. It applies to stars, planets, and distant galaxies alike. Time is the delay between something happening and you seeing it. Matter comes next. Matter is anything that has mass, and it is built from atoms. Atoms are the small building blocks that make up physical objects. This matters because matter is what stars, planets, and people are made of. Without matter, there would be nothing solid anywhere in the universe. A bathroom scale only works because your body has mass. The scale measures how strongly gravity pulls on that mass. Without mass, there would be nothing to weigh and nothing to measure. Confusing matter with weight causes real problems in engineering and shipping. A shipment gets mislabeled because someone used weight instead of mass. The numbers do not match once the shipment crosses into a different context. That mismatch can delay a shipment or trigger a costly recalculation. It sounds like a small detail until it holds up an entire delivery. Matter is the physical stuff that makes up everything you can touch. Energy follows matter closely. Energy is the capacity to do work or cause change. Nothing moves, heats up, or transforms without energy behind it. This matters because energy powers every process, from starlight to your own muscles. A car engine converts fuel energy into motion that moves the vehicle forward. That conversion is never perfect, and some energy always gets lost as heat. Some engines do this more efficiently than others. That difference is why fuel mileage varies between cars of similar size. Poor energy conversion wastes fuel and costs you money at the pump over time. That same idea applies to appliances in your home, not just engines. A less efficient appliance quietly costs more to run every month. Energy is what makes change happen anywhere in the universe. Gravity is next, and it ties matter and energy together. Gravity is the attractive pull between anything that has mass. The more mass an object has, the stronger its pull. This matters because gravity holds planets in orbit and shapes entire galaxies. Without gravity, planets would drift apart and never form at all. Drop a wrench on a job site and it falls straight down every single time. It falls at the same rate no matter how heavy the wrench is. That constant, predictable pull is exactly why safety harnesses exist. Fall protection on construction sites is built entirely around gravity's constant behavior. Engineers do not guess at how hard something will fall. They calculate it, because gravity behaves the same way every single time. Gravity is the force pulling any two masses toward each other. This is the important part. The Big Bang is the origin point for everything just described. The Big Bang was the rapid expansion of space from an extremely dense starting point. This happened about 13.8 billion years ago. This matters because it explains where everything came from. It explains this without needing anything to explode into. It was not an explosion happening inside existing space, it was the start of space itself. Think of bread dough rising in an oven. The dough expands and stretches outward on its own. It does not explode outward into the room around it. That is closer to what the Big Bang actually was. Misunderstanding this leads people to picture a fireball in empty space. That picture is not accurate, even though it is common. The Big Bang was the beginning of space and time together. It was not an explosion happening within space that already existed. Expansion of the universe follows directly from the Big Bang. Space itself is stretching, and this stretching carries galaxies farther apart. The galaxies themselves are not flying through space like debris. This matters because it explains why distant galaxies appear to move away faster. The farther a galaxy is from you, the faster it appears to recede. Astronomers measure this using something called redshift. Redshift is a stretching of light waves as an object moves away from you. That measurement is how scientists calculate that the universe keeps expanding. It also shows that the expansion itself is speeding up over time. Expansion means the space between galaxies keeps growing as time passes. Galaxies are the next concept. A galaxy is a massive collection of stars, gas, and dust. Gravity holds all of that material together as one structure. This matters because galaxies are the basic neighborhoods of the universe. Almost everything you can point to in space belongs to one. Your home galaxy is called the Milky Way. It contains hundreds of billions of stars, including the Sun. It is one of roughly 2 trillion galaxies estimated to exist. Most of those galaxies are too faint to see without a telescope. A galaxy is a gravity-bound cluster of stars and material. Nearly everything visible in the night sky belongs to a galaxy like this one. Thinking of galaxies as neighborhoods makes the scale easier to hold on to. Stars and their life cycles come next. Stars form, burn for billions of years, and eventually die. The way a star dies depends heavily on how massive it was. This matters because dying stars manufacture the heavier elements in the universe. Those elements later become part of planets, tools, and living things. The iron in your blood came from a star that died long ago. The calcium in your bones has the same kind of origin. That is not a poetic statement about connection to the cosmos. It is literal chemistry, confirmed through direct measurement of starlight and matter. Scientists can read the exact chemical fingerprint of a star from its light. That is how they know which elements came from where. Stars are the source of most heavy elements found anywhere in the universe. Dark matter and dark energy are the last core concepts. Dark matter is unseen mass that does not emit or reflect light. Dark energy is an unexplained force driving the universe's expansion. Neither one can be observed directly with current instruments. This matters because visible matter alone cannot explain how galaxies hold together. Galaxies spin fast enough that they should fly apart without extra mass. Visible matter also cannot explain why the expansion keeps speeding up. Structural engineers sometimes add a correction factor to a calculation. They do this when the real-world numbers do not balance without it. Physicists use dark matter and dark energy in a similar way. These factors make their models match what they actually observe in space. This is not a guess added to cover a mistake. It is a measured gap between what should be true and what actually is. Dark matter and dark energy are unseen factors that make the universe's math work correctly. Let me show you exactly how this works using one real situation. Picture yourself outside at night with a basic telescope. You point it at a faint point of light and look closely. That point of light is not a single star. It is an entire galaxy, made of billions of stars packed together. That is the concept of galaxies in action. The light entering your eye left that galaxy millions of years ago, so you are seeing the distant past, not the present moment. That is the concept of time in action. The image also looks fainter and redder than expected. This happens because the galaxy is moving away as space itself stretches. That is expansion happening in front of you, in real time. None of this would be visible if light had nowhere real to travel through. Light needs a real, measurable dimension to cross to reach your eye. That dimension is space, the third concept working in this same moment. One more piece completes the picture. The telescope's mirror only gathers light because of gravity. Gravity is what holds the glass in its precise curved shape. Gravity also keeps your feet steady on the ground as you look through the eyepiece. In this one simple act of looking through a telescope, 4 ideas are working together. Space, time, expansion, and gravity all act at once, in the same instant. Here's what people most often get wrong. The first mistake is picturing the Big Bang as an explosion happening inside space. This is easy to do because the word bang suggests a detonation. The fix is to remember the bread dough example from earlier. Space itself was expanding, not exploding outward into a room. The second mistake is assuming the universe has a center or an edge. This is easy to assume because every object in daily life has both. A house has a center. A parking lot has edges you can walk to. The fix is understanding that expansion happens everywhere at once. It does not happen outward from one single point in space. The third mistake is treating dark matter as something ominous or shadowy. This happens because of the word dark sitting right in the name. The fix is remembering it is called dark for a simple reason. It does not emit or reflect light, and nothing more than that. The fourth mistake is mixing up mass and weight in conversation. This happens because both get casually called weight in everyday language. The fix is remembering that mass stays fixed no matter where you are. Weight changes depending on gravity, such as weighing less on the moon. The fifth mistake is assuming that looking into space shows things happening right now. This feels true because your own vision seems completely instant to you. The fix is returning to the 8-minute sunlight example whenever distance comes up. This understanding has real, practical uses. Knowing that light takes time to travel helps you read space news correctly. A headline about a star exploding often describes something from centuries ago. Misreading that spreads outdated information as if it were breaking news today. Knowing how gravity governs orbits explains why satellites stay in place. GPS, weather, and internet satellites all rely on the same predictable pull. That understanding makes technology news about satellite launches actually make sense. Knowing about expansion clears up an apparent contradiction people run into. The universe is 13.8 billion years old, but looks far wider than that number suggests. Without this knowledge, that fact looks impossible and gets dismissed as nonsense. Knowing where heavy elements come from gives you a grounded answer. It helps when someone asks where metals and fuel originally came from. Instead of a vague shrug, you have an actual, accurate explanation ready. These are not abstract facts you will never use again. They come up in news stories, casual conversations, and questions from people around you. You can now explain why the night sky shows you the past. You can now correct someone who describes the Big Bang as an explosion. You can now tell mass and weight apart without mixing up the terms. You can now explain why the universe has no center or edge. You can now follow space news without being misled by delayed headlines. You can now hold a real conversation about how the universe works. None of it requires memorizing formulas or technical terms. It only requires the handful of ideas you just walked through. You now have the understanding of the universe you should have had all along.